So earlier we isolated the solid product from the reaction of morpholine with tert-butyl acetoacetate. And it won't be dry yet, but we can run GCMS spec on a wet sample because a little bit of water or solvent won't affect the position or the retention time of the compound. So I've got a vial for a GCMS spec labeled 60A. We already have our other sample from the cold reaction, 46B, made up. And we are just going to dissolve a little bit of this solid, the 60A, in dichloromethane in the vial. And it's a little bit of a pain to get the solid in there, so I'm going to use a disposable test tube to make up my sample. Doesn't take very much solid. You just take a little bit on the tip of a spatula. That's plenty. And we can stick that back in the desiccator to continue drying, so that when we take our NMR we have a nice dry sample. And we'll just take a little bit of dichloromethane, about a milliliter and a half, and dissolve that up. Very pale yellow solution. And we'll transfer that to a GCMS spec vial. So we have our two solids now, the cold reaction being 46B and the hot reaction being 60A. That's not very dirty, we'll just give it a little wipe. And I also need to refill the methylene chloride wash bottle over on the GCMS spec. I'm going to go over there with my two samples and my bottle of methylene chloride. And I just remembered that I did not reset the camera angle from looking at the computer, so you probably saw the back of the hood while I was preparing those samples. Anyway, I'm going to put 46B in the first slot of rack number 2, which means it will be vial number 26. And I'm going to put 60A in the second slot in rack number 2, which means it will be number 27. The instrument is actually running, and it is 5.47 minutes into a 10-minute run, so I have plenty of time to take this sample out and fill it with dichloromethane before it tries to move that rack. Obviously, I want to make sure that it's not trying to move the rack while my hand is in there. So we're just going to refill that wash vial with dichloromethane. Put that back where it came from. And set these aside to take back to the hood. Because the instrument's running, I can't set anything up in the real-time analysis software. But what I can do is open up the GCMS analysis editor, which will allow me to set up a batch file without affecting the run in progress. So I'm going to open that software, and I'm going to point that to my folder where I've got GCMS spec, and then I've got something called 2021 Labs in there. I'm going to point at that folder. And now I'd like to set up a batch file to run those two samples. So I'm going to go to batch processing. And I'm going to go to the file menu and open a batch file. And I believe that under GCMS batch files, I have stored a batch template right here. So I'm going to open that batch template, right, which has the basic information that we're going to need in it that I can use to fill out my batch file. So I have my vials in number 26 and number 27. I'm going to want an injection volume of about 0.5 microliters, both cases. My spectrum number is DCL-10- what were those lot numbers? 46B, 60A. 46B-1 and DCL-10-60A-1. The method file that I want to use for this, I have under GCMS spec, GCMS methods, called Morpholine. Ooh, that's not there. Alright, so under data, GCMS methods, there should be one called Morpholine solids. That's the one I want. Put that in both places. The tuning file I'm going to want is the most recent result, which is not March 18, 2013. That's 3/17/19, so I'm going to change that. Data file, I got to get a data file. So we're going to store that in my folder, which is under J data. DC Lever, GCMS 2021 labs, and this material is solid from cold reaction. I'm going to copy that, Control C, so I can have it, and I won't have to retype it. I can just paste it in there, solid from hot reaction. And again, stick that in my folder. GCMS spec 2021 labs. And then the reaction that yielded that was reaction of morpholine with T-butyl acetoacetate. In the presence of molecular sieves, 3A molecular sieves, at low temp, or at basically 0 degrees, or in the freezer probably a little less than 0 degrees. I'm going to copy that because the data description for the other one is simply going to be the same thing, except not in the presence of 3A molecular sieves and at 170 degrees instead. You'll notice it created row 3 while I was working on row 2. It always does that. So just check the batch file and make sure everything's there. Vial 26, vial 27, injection volume of 0.5 microliters. 46B, 60A, morpholine solids is the method file for both of these. The data files are solid from cold reaction, solid from hot reaction, and then my tuning file and my data description. So I can delete row 3. I can save this batch file as, and we will call this morpholine batch. So we've got our morpholine batch file saved. The other thing I can do while I'm here is I can open that method file, which was under data, GCMS methods, and I can make sure that it is what I want it to be. So you'll see I'm washing with the solvent twice, pre-run, twice post-run, twice with the sample, and under advanced, I'm washing with only B, that's the dichloromethane, A is methanol, and C is acetonitrile. I'm pumping twice, and I'm washing with 6 microliters each time. That's good. On my GC, I'm going to start at 80 degrees and hold for 2.5 minutes, and then rise at 30 degrees per minute to 245, at which time I hold for 2, so a 10-minute total run. The mass spec is SHRXI 5-sil-MS, 5% diphenyl, 95% dimethyl polysiloxane, film thickness of 0.25 micrometers in a standard 30 meter by 0.25 millimeter inner diameter column. The injection temperature is at 280, that's the injection port, and we're running a flow of 1.19 milliliters per minute at 80.7 kilopascals and a split ratio of 25. So our linear velocity is about 40 centimeters per second. Under the mass spec, the ion source temperature is at 200 and the interface at 280. We have a solvent cut time of 2 minutes, and then we're collecting data from 2.1 to 10 minutes between 50 to 400 mass over charge ratio, or 15 to 400 AMU. So that's our method. It's a good method. We can close that file. And now we can close the analysis editor and go back to real-time analysis. It's still in the middle of running this other batch file, but I can go to the batch processing, and then under batch I can go to where it says batch Q, and I can add that morpholine batch to the batch queue. And now when it's done running this bromination batch, it will immediately go to adding my morpholine batch. So we'll just wait. It's going to be over an hour because it's got to run the rest of the bromination samples, and then it'll run our morpholine samples as well.